Alrighty. Yeah.
Oh yeah, I have one open right now.
So if you want to follow along, go for it. I don't want to get too bogged down trying to help dissect questions and whatnot in real time, because that went a little poorly last time. Although we have a much smaller group, so I don't know. We'll see. We'll see. Alrighty. So brick break or breakout, whatever. Here's the editor. It's open. We got to start with something. The game is decidedly going to be in 2D. So I'm going to make 2D root node, put a script on it. Let's just call it game for now. Okay. All right. What do we need? We lost someone. Who do we lose? We lost Jordan. That's fine. We need a player. We also need a ball that's going to be bouncing around and bricks. So one of the differences from what I'm going to do here from last Friday when we made Pong, I did it the hard way, where you got to implement the detection of collision. I normally do that in person so that people obtain an appreciation for using other systems that solve these sorts of problems. Trying to implement your own collision detection, it's tough. And even if you get it like working, it's ugly. It's, getting it clean and smooth is a very difficult proposition. So I like to do that at first. For here, we're going to use physics, like actual built-in physics stuff. We don't need to implement, detecting is this thing touching that thing and where at, how so, and movement, blah, blah, blah. That's already going to be done. Mostly, we'll have to configure some of the data. So with that being said, we need to make our separate pieces of the game. Player, brick, and the ball. Let's go with the player first. So what do we want the player to be? It's gonna be... Is it a rigid body? No, it's a kinematic body. I don't do physics a whole lot, so I always forget. Okay. So we can add a node. Godot has these nodes called kinematic bodies. I added one here. You'll see it's got a warning. What's up with the warning? Hover over it. It needs a shape. Okay. This node here is a node to handle the physics signals and processes, but it still gives you the freedom to define the shape of what it is using to do these interactions, these physical collisions and movements. So let's add that. Let's add collision shape. Collision shape. We're going to go over here to the right, inspector, and give it a shape. This is going to be the player. So that's going to be a paddle. You know what? I'm actually going to change this. No. I'll change it later, and I'll show you why. Let's just do a rectangle for now. Go into 2D view so we can see it. Here it is. Let's extend this. Great. Save this as game. We run it, and we see nothing. What's going on? You have a physics body, but physics doesn't have like a visual. Godot does provide it. Visible collision shapes as an option here. So now we can actually run this. And now we can see on the top left corner, the little thing there. Let me move that over here so you can see it better. And look at that. We have our rectangle. This is the player. Okay, let's make it move. So last time with Pong, we made the paddles move up and down. We did that in the process function. Here's something you need to know when you're using physics. In most engines, and frameworks even, you normally actually have different loops for different processes. One for rendering, one for physics is the typical setup. And that's what we have here. We have a process function. We also have a physics process function. What's the difference? Process is going to try and run as fast as it possibly can. If you don't have vsync on and you've got a good setup on your hardware, it'll run several hundred, several thousand FPS. So be it. Physics process, on the other hand, is going to attempt to run at a fixed rate. I think the default is 60 here. Let's do physics, 2D, do we have it here? Comment, yeah, physics FPS. It's going to try and hit 60 frames per second. Why would you want that? As a quick over-level answer, it's because physics is heavy. Actually, going into how to implement collision detection, movements of physics, and all these different things, it's really expensive on the CPU. And so, make it into its own separate thing that runs, at a lesser rate. You'll often see many games, the FPS, the visuals, several hundred. The physics, locked to 30, locked to 10 even. It's just computationally expensive. All that said, just be aware of it. For our sake, we just need to know, you want to move something that's using physics, do it in the physics process, and you're good to go. All right, so let's do that. Movement slide. If we want to go to the left, we do minus 400. 400 is just a number I picked out of nowhere. Okay. Can y'all see a difference between how I'm moving this versus how I did it in Pong last Friday?
I don't know.
You'll notice I'm not multiplying by delta.
Oh, yeah.
Why is that?
That does make sense. Well, didn't you say you fixed it to didn't you say this function was fixed to 60? I guess refresh rate. I don't know how else to put that.
It's attempting. And I say that being extremely pedantic. Excuse me. For the most part, this is going to run at 60. It's going to do a good job at it, but it can't guarantee it. And so it'll attempt, is what I'm going to say.
Oh, okay.
But there is the chance that, yes, it could run at some frame a little slower, a little faster.
So it'll just run it like at whatever it can and up to 60? Is that what you're saying?
I don't know the exact details of if it's going to do frame skips for compensation, this and that. But it is going to attempt to run at that fixed frame rate. However, it still provides you delta, right? Because it can happen where some frames are slower, some are faster. And so here's, your delta variable to take into account delta. So you see here, they're mostly running at the same exact frame rate.
Okay.
Okay. So I set it to 400. So I'm moving at 400 frames per second to the left and to the right, but I'm not multiplying by delta. This is a bit of a particular caveat. I'm using move and slide function from kinematic body. This function itself already takes into account delta. That's all the answer really is there. But I do want to point this out to show light that these physics systems are big and complex. They have a lot to them. This one function, here's the documentation in code for it, for move and slide. And so if you're ever going to go into using physics systems, please be aware of what you're doing. This is a bit of my paranoia. I don't like doing physics in games for reasons like this. But yeah, good habit. Be aware.
Is Godak the only one that has this, I guess, physics compression where this is a lot simpler than what we put in last time, right, with Pong? do other if I use Unity, does it have like its own, I guess, shortened version to physics, so I don't have to like
Yeah,
sort
you'll
out a
see
bunch of
this.
stuff?
You'll see this the same in all the other engines. You'll probably even see better implementations, to be honest.
Mhm.
There are also just these external libraries. So Bullet 3D is a library for handling collision all on its own.
Oh, sick.
It's just a piece of software. It's not tied to an engine, but many engines do implement it, right? Like it's just if you're coming from Python or Java, C Sharp, C++, import library.
Yeah.
This is the same thing with Bullet. I think Godot in some versions had Bullet as well, and there's other ones out there.
Okay.
I just generally don't start people off with using physics so that they can build an appreciation for when they do get to use it. And it's, oh my goodness, it's so nice. It takes care of all these amazing hard problems. You don't get that appreciation if you don't struggle, in my belief. Anyhow, we've got input. You can move left, you can move right. This already takes into account delta. Okay. So here's our player. I'm moving left, I'm moving right. Awesome. It can move off screen. It can move off screen to the left, off screen to the right. Let's fix that, I guess. I'm just going to move the player to the bottom of the screen here. I need to fix this transform. All right, let's put the player here. All right, since we're using physics, we can do something a little cheaty. We can create an actual physical body that's not going to move and that the player can't move like against. We make a wall that the player can bounce against, or not bounce, get stopped by. So let's do that. Let's see. So for a body that we want to not move, let's do static body. Now, for this one, I'm going to do a polygon, collision polygon. Now here's a cool little thing about the collision polygon. You can actually you can draw the shape out yourself. So let's do something like this. Let's just move it. All right, look at that. We got some slanted walls here. You can slide against them. Not what we want, so I'll fix that, make them straight. But pretty cool. You can make collision as you need. Let's see, do we have grid snap? We're going to use our amazing editor here to get these pixel perfect. Okay. So now those should be good. Not sliding on the left. Not sliding on the right. Great. We've blocked the player in. Superb. All right. What do we need next? We want the tiles that the player can break or the ball. Let's do the ball. What do I want for this one? I think I'm going to go with a rigid body as well. Alrighty. Gotta give it a shape as well. This one we can say is just a circle. Put this over here, run this, we'll see what happens. Y'all see that?
Oh yeah, the tiny circle on the bottom.
Yeah. Why did it move?
Didn't you move it?
No.
Or no? You didn't move it?
We moved the paddle.
Oh, that's cool.
So they've already set up the rigid body to have some assumptions about what people want when they're doing physics. In this case, platformer, Mario side 2D view. So what's going on is that this has like gravity affecting it. And so I'm going to go into the rigid body and override some stuff. It's got a physics material. Let's give it a new one. So now we can go in there. We can make some edits. Bounciness. Oh, whoops. I thought that was maxed to 1. We'll put that to 1. Friction, 0. Outside of that, gravity scale. Let's say no gravity. So 0. Is that everything we need? Maybe. Okay. Make sure there's no damping of anything going on here. Okay. And let's apply a velocity. Let me do 400 on the x-axis. And look at that. We got a ball. It's bouncing around. Let's do some on the Y. Can you move around? Superb. So now we have a ball. It's bouncing around off the walls. It's bouncing off the player. Is it slowing down? It is.
It is.
Oh, I didn't set the... I thought I set the damp. All right, now it shouldn't. And it's not. Okay, so on the stream, I don't know if you can see. Can you see how anytime it hits the wall or the player, it makes a little red dot?
Oh yeah. Is that because they're overlapping or what?
So that's Godot's collision debugging, showing you, hey, there's a collision here. And so when there's a collision, it only lasts for like a frame or so, but for that frame in which it exists, it'll give you the actual visual of here it is. And so you have this collision report. It's got data of what is hitting what, position, velocity, directions, etc., so that you can respond to them and do what you need to do appropriately. Ball is tired. Okay. Alrighty. So now we need a brick. Let's have a brick to break. We're going to want that to be not a rigid body, but another static body. So let's do that. Static body here. Collision shape. And we'll make that a rectangle. Okay. We'll put that there. See if it works. So now on the paddle on the bottom, there's the brick on the top. All right, let's make it break. Okay. Where is my ball? I should rename all these now, so I'm getting lost. Let's name this ball. And this here is brick. These are walls, and this is player. Okay. This is off center. Let me fix that real quick. Now that's lined up. Okay. So, something a bit specific to Godot. Godot has a system of signals. It's how you can get a bit of, I don't want to say it's asynchronous. I forget what you call it in other languages and paradigms. Callbacks and alerts, maybe? So Godot has a system where a node can fire off a signal for when something happens. So for an example, a button. A button has a signal for pressed. So when it gets pressed, it'll fire off a signal called button pressed or whatever you want to call it. The interesting thing about that is you can have any other node listen to that, right? You can tie a node or to have a node look at another node and listen and tell it, all right, hey, look, when that signal fires off this signal, when that node fires off a signal, you can respond. You can do something in response to that signal. You can even carry the signal data. So now you have the data associated to that signal. Why did I bring this up? Physics stuff, or physics nodes have a bunch of useful signals. If we go to the right over here, by inspector, we'll see the node. We've got some signals here. We have the ones for being an object, the node, a canvas item, all the way up to a rigid body. Let me just double check which one do I need to fire off. All right. Body entered. And that's connected here. Okay. Okay. I have connected the ball node. It has a signal on body entered. It's going to call this function here. It gets passed over the information of the body that entered it, and we'll print that out. Uh-oh, did I do the wrong one? Oh, no, I forgot. I need to make one change here. Contact monitor needs to be on. I think maybe contacts reported. Okay, had to make a couple changes real quick. So now this ball, when it's colliding, it's firing off a signal and telling me what is it hitting. And so you'll see it here, it prints every time it hits the brick. There's the brick along with what node it is, or a reference to its node. Same with the player. All right, so that's really cool. When the ball hits something, we have access to that node. So what can we do? We can delete that node. Let's do that. Body.QFree. Oh, would you look at that? The player's gone.
Oh no.
The brick is gone. So we kind of got half of what we wanted. All right, that's cool. Let's fix that in an easy way. Here's the other portion or another idea that with signals it's really powerful. You can tag nodes. So in Godot, we call this groups. The brick. Charlie says he knows how to fix it. Pick me. He's raising his hand. What's up, Charlie? How do you want to fix this? All right. And they said never mind. Okay. So we go to the node. On the right of the inspector, not of the inspector, but to the right of the inspector, the node view, we got signals. We also have groups. So let's add the brick node to a group. We'll call it brick. Okay. And this is nothing more than just a tag. So you can tag all these nodes as being part of various groups. And there are a few things that you can do with that are really powerful. For example, you can ask a Godot, give me an array of all the nodes that are in some group. So if you're making an RPG with a bunch of different enemies, at any point dynamically, you can say, hey, grab all the nodes that are in the group enemy. And so now you have that list instead of having it cached. And you can do a bunch of stuff, and then you can start firing off signals with them or doing whatever you need to do. In our case, we can just add the brick to a group, call it brick, and we can check. If the body is in group brick, then we'll tell it to delete itself. Let's see if that runs. It does. Look at that. So the brick got deleted, and the player does it because it's not in the brick group. And so we've got brick break. It works. We did it. It's not much, but it's mine. I love it. We do need more bricks, though. All right. Sorry for the coughs. Let's make more bricks. So I can copy paste these here. So here's a, if you're ever just testing stuff out, this totally works. And so now let's see if it does actually. Oh, what the heck?
Oh.
I tried to move and something broke.
Oh, that happened to me literally right now because I was following you along. It's because you still have it named Kinematic Body 2D.
Oh.
Yeah. I looked through mine and I was trying to figure it out, and then I saw that.
Whoops. Okay, I can move. Superb. We deleted one brick. We deleted a second brick. Awesome.
Nice.
And it's not deleting the wall at the top. It's not deleting the player. It's not really moving anywhere, though. We could fix that somehow, right? Let's fix that for now. So there are multiple ways of fixing it. I'm gonna cheat and use physics to my advantage. And so this collision... Uh-oh, phone alarm. I'm gonna change it from a collision shape on the player to a polygon. Change type, collision polygon. All right, and so I'm gonna do something like this. Let's make it a little bigger. That's, oh my goodness. One, two, three. 1, 2, and 3. Okay. Oh my goodness, that's too big. Okay. Let's dial this in real quick. Super. So now instead of the player being a flat rectangle, it's a, what do you call this? An obtuse triangle? It's a triangle. And so if it hits to the left or to the right, it should bounce just a little. If we want this to be more severe, we change the angle of this. And so that's some of the cool stuff about using physics. You can get away with doing things like this. Now again, these aren't the actual visuals, right? We're only seeing these shapes here because we have visible collision shapes. If we turn that off, we see nothing. So let's give these shapes some actual visuals. For the player, I downloaded an asset pack of some visuals. Nothing amazing. I'll link them later if y'all want. But it should give me what I need. There's our paddle. That's too big. Let's just scale this down. Dr. Mario pill. So we'll just make this kind of fit loosely. And would you look at that? We got a ball, or a paddle. Let's do the same for the ball. Black, blue, gray, or yellow. Somebody pick.
Blue.
All right, blue. Pink is not an option. All right. Oh, this one's got a little highlight on it. Ball's over there. One, two. 0.18. Still too big. Okay, that looks pretty good to me. So now we got a ball, and it's bouncing off our paddle. We know secretly it's bouncing off, something else. I'm not an artist. You can make these visuals look much better. All I care about right now is making it work. And this works. The bricks need a visual. So let's give the bricks a visual, and then we'll do something a little more complex. Tile, we'll do black tile. Oh, no. All right, that's good enough for me. And let's spawn several of these. Oops. Just litter the field, make sure things are working. So if you hit the paddle, if the ball hits the paddle to the left, it goes a bit to the left, and so on for the right. Oh, look at that! It bounced in between two of them. Awesome! It's like the actual brick break and breakout games. Very cool. Okay. Now, me having to copy paste the tiles is getting a little tedious and cumbersome. So let's do something a little different. Instead of just having bricks that I'm manually placing, let's see if we can generate them instead and place them down programmatically. The ball should probably just start here. Okay. So what do I want to do? In Godot, I can instance a scene however I want. Just a node I can't. So what am I getting at? I can save this node here, the brick node, as a scene. Let's do that. Save branch as scene. This is brick, yes. And so now that's there. Let me double check that this is still gonna work just fine. Yes, okay. Okay, so let's make a reference to that scene. We'll call it brick equals preload and then have that scene. And so now we have a reference to what that scene is. It's not a scene itself of the brick. It's a means by which we can look at a file describing what we want. And later we can create them. In our ready function, for example, let's create one by hand. Our brick equals big brick dot instance. And then let's delete this one over here. Okay, so in our tree, we don't have any bricks anymore. There's none there. I have a code here to instance one. What happens? Nothing. We did instance it, but we didn't add it to our scene tree. Add a child brick. Okay. Whoa, look at that. Now we do have one. So what's going on here? Harkening a bit back to Pong, Godot itself works off using various nodes. We have our root node here, and we have all these subnodes that are different parts of our game. Godot, for the most part, will only handle things that are in the tree. All nodes have a process function, ways of being displayed and handling themselves. And so if you throw a node into the tree, all these things start to kick into effect, and you can have it be this living system. If you don't, if you created a node but you haven't put it in the tree, nothing's happening with it. It effectively doesn't exist. You can use that to your advantage for doing prep work. So let's say before we add it to the tree, brick dot position. Let's change its position. Let's set that to 0, 0. Why not? And then we add it to the tree. You can kind of let me change this to like 100, so you can see it. So you can see the brick is on the far left of my screen, right, top left corner. And then I added it to the tree. So yeah, I had a phrase or a bit of a line of thought I was gonna give at the end of this little tangent, and I forgot it. Oh well. We're able to generate bricks. We can change their position and then add them to the tree, and so they appear at the position we wanted. Cool. Let's do that for a set number of bricks. So I'm gonna make a function that'll just do this work for me. Function generate bricks. You know what? It can give it'll take in a number. Should I take in 2? Let's take in 2 numbers, width and height. Rows and columns. Rows, columns. And so what we're gonna do, we're gonna move this code over here. Generate bricks. Let's do 3 by 4. Okay. In this code, let's make it where we'll generate bricks corresponding to the rows and columns. For X in rows. If I have these reversed, don't pay attention to it. X. So let's give it an offset of 300 and then plus X times, I don't know, we'll do 100. And we'll repeat this for Y. Okay. Oh, that was way too close. Y offset. We'll just do like 10. The difference between them, let's move that down to 40. That looks better. They're still too close on the X. Let's do 200. Awesome. That looks better than I expected. Let's get this a little tighter. 20. Too tight. 30. Okay, cool. So what I do here? Created a function. It takes in 2 numbers, rows and columns. For each one, get my instance of brick. And again, brick is just pointing. It's a reference to what a brick ought to be. So it's looking at this file over here, brick.scene. And so we can look at the brick. We've defined it as being all this here. A brick is just, what kind of node is this? A static body with a collision shape and an image. So we're generating it, changing its position using the X and Y intake to figure out where we want it to be. And then making them. And they all still do get deleted, by the ball. Oh, look at that. Great. Cool. How much time we got? 47. Let's do one more little thing here just to show off like a different aspect of Godot, or an extension. Using these node systems, we've got the 2D stuff going on in here. We also have nodes for handling 3D stuff. Those are called spatial. We also have these other ones, control nodes. People get scared of these. What are the control nodes for? Control nodes are for handling UI. This is one aspect where Godot has a really good upper arm or strong arm over Unity, Unreal, and any other engine for the most part. I've worked with a lot of people who had never touched Godot, and when they start touching the UI, the control nodes, they all love it. So this is where we can handle UI. I'm gonna have a score counter at the very top. So let's choose a label. All right. Put that over here. All right. I need to... Let me do this. Let me just change this the ugly way for brevity's sake to fit my screen size. Not my screen size. What is... I forget the default window size. Oh my goodness. Window. 1024 by 600. Just copy that. By 600. Perfect. We'll put the control node there. We'll tell the the label. Go to the center top. Text. Here's some text. Awesome. Align it to the center. Run this. Oh my. Where is visibility? Can I move it over here? One sec. I'm just trying to orient these. Nope. Oh my goodness. I forgot how to... Okay, I'm gonna cheat this. Do this a different way here. Make the offset here. Cool. We'll do something like 40. There's a better way of doing this. I'm just trying to be quick about it. Ideally, you would actually have the control nodes on a whole separate layer by using canvas layers. And so now you have your UI being rendered completely separately from the game. Right now, I didn't do that. I just threw it in there, manually resized it. It's real quick and dirty to get text on the screen. And so it can get interference with the game itself. Where did the ball go? Did it go all the way? Oh, it just went down. Okay, so what do we want to do? Let's do something simple, like when the brick gets destroyed, we'll update some score counter. Our score is 0. Let's have a function to update the score. And all we'll do is change the text of that label to be the string of whatever the score is. We'll run this function at the beginning. already, so that way instead of it being my really bad lorem ipsum, it'll actually be the score 0. Great. Let's do something a little fancier. Let's do score colon number. Superb. And every time we destroy a brick, we'll increase score by 1. Update score. Cool. So now when a brick gets destroyed, score goes up by 1. Look at that. This is a game. Let's get rid of some of these little print debugs that we still have in the game somewhere. Here they are. Okay. I know that was a lot. It was really quick, pretty dense, and I skipped over a bunch of details. But hopefully this shows you a little more cleanly from last Friday. You can get up and running pretty quickly with Goodell. For the sake of the workshop, the workshop's done. This is recorded, so if anyone wants to follow along with this, that'll be up on YouTube. I'll upload it myself. That way it's a source video and audio and not, streamed audio and video.